Hi everybody, in this video we are going to learn the product rule, quotient rule, and power rule for logarithms. When you learn something new in math, there's usually a product rule and a quotient rule and a power rule to go along with it. You just want to know what happens when you multiply things together, when you divide things, when you raise to a power. So when you learned about exponents, you learned the product rule, the power rule, the quotient rule for those. We're going to do the same thing today with logarithms. When you go to learn calculus, when you learn about derivatives and integrals, you'll learn product rules and quotient rules and power rules for those. So get used to it. So these are the product and quotient rule and power rules for logarithms. We'll start with the product rule here. If we are taking the log, if we have two numbers a and b, and we multiply them together, and then we take the logarithm to a base of c of a and b, then that's the same thing as the log of a base c plus the log of b base c. So let's prove that now. So let's say we have this number a, and the log of a to a base of c is equal to some number, and we'll call that number capital A. Okay, and then we have some other number lowercase b, and when we take the logarithm of that number to a base of c, then we get this other number which we'll call capital B. Then what happens when we multiply a and b together and take the logarithm of that? Well, from this equation over here, we know that c raised to the power of capital A is equal to lowercase a. So over here we can replace the lowercase a with c raised to the power of capital A. So this whole thing is equal to the log base c of c to the power of capital A, and then times b. But from this equation we know that c raised to the power of capital B is equal to lowercase b. So we can replace this lowercase b with c to the power of capital B. All right, and now we can use our product rule for exponents, which we learned earlier. C, these both have the same base, c. So c to the a times c to the b is equal to c to the a plus b. Remember, just your laws of exponents. When you multiply two numbers together that have the same base, the exponents get added together. So we can rewrite this whole thing as the log base c of c to the a plus b. Okay, now this, remember the question that we're asking when we see something like this. So we're asking ourselves, c raised to what power is equal to c to the a plus b power? Well, that must be a plus b, because c to the a plus b is equal to c to the a plus b. So over here we just have a plus b now. And now we're just going to go back to what we said earlier over here, which is that a is equal to the log of little a base c. And then we have plus capital B, but B is just equal to the log of little b base c. Okay, so we have just shown that this is the same as this, which is what was written over here. So we just proved the product rule. All right, now let's take a look at an example of the product rule. Okay, so we're going to do this two different ways. We want to take the log base 2 of 16 times 4. Well, one way that we could do that is to simply say that 16 times 4 is 64. So this is the log base 2 of 64. And then we can ask ourselves, 2 raised to what power would give us 64. So let's see, 2 to the first power is 2, and if we multiply by 2 again, we get 4. Multiply by 2 again, we get 8. Multiply by 2 again, we get 16. Multiply by 2 again, we get 32. Multiply by 2 again, we get 64. So 2 to the 6th power, see, 6, is 64. So this is 6. Now let's go ahead and use this product rule to figure this out another way. So the log base 2 of 16 times 4 should be equal to the log base 2 of 16 plus the log base 2 of 4. Well, what's the log base 2 of 16? Let's see, 2, 4, 8, 16. So 2 to the 4th power, right? 2 times 2 times 2 times 2, 4 times. That would be 16. So this is 4. And we have plus 2 to what power is equal to 4? Well, 2 to the 2nd power, which would be 2 times 2 is equal to 4. So this is equal to 2. So we have 4 plus 2, which is 6. Same answer that we got over here. Okay, now let's move on to the quotient rule. So now we are dividing A and B. And so here's the quotient rule. When A and B are being divided, then this whole thing would be the same as the log of A base C minus the log of B base C. All right, so let's prove that, and then we'll do a couple more examples. First, the proof. So again, we're going to say that the log of A base C is equal to capital A, and the log of B base C is equal to capital B. Then we want to know what the log base C of A divided by B is. Well, again, we know that C to the power of capital A is equal to little a, so we can replace this little a over here with C to the power of capital A, and we can replace this B with C to the power of capital B. So we can rewrite this whole thing as the log base C of C to the capital A over C to the capital B. And now going back to our laws of exponents, we know if we're dividing two things here and the bases are the same, then we would subtract the exponents. So this whole thing is just C to the power of A minus B, which means that this we can rewrite as the log base C of C to the power of A minus B. Okay, we've just rewritten this as this. And again, when we have the log of something, when we're taking the logarithm of something, we're asking ourselves, this base raised to what power would give us this? Okay, so C raised to the A minus B power would give us C to the A minus B. So that's what we're going to put here. Right, now A is just log base C of little a, and then minus capital B is just log base C of little b. Okay, so this proof is very similar to the first proof that we did. And there it is. So we've just proved that this expression is the same thing as this one, which is exactly what we have over here for the quotient rule. Now let's go ahead and do the power. I'm sorry. No, we're still going to do some examples of the quotient rule. All right, so let's figure out what this is in two different ways. We have the log base 5 of 125 divided by 25. Well, what's 125 divided by 25? 25 goes into 125 5 times. So we have, this is equal to the log with a base of 5, the log of 5 with a base of 5, okay? Because this divided by this is 5, okay? Keeping this the same. Okay, so 5 raised to what power is equal to 5? That would just be 1. Okay, so this is equal to 1. Now let's do that a different way using the quotient rule. So this, using the quotient rule, should be the same as log base 5 of 125 minus the log base 5 of 25. Okay, so what are these two things? Well, the log of 125 base 5. So we're asking ourselves 5 raised to what power is equal to 125? Let's see, 5 times 5 is 25. And if we multiply by 5 again, that's 125. So this would be 3. And then we're subtracting the log of 25 base 5. So we're asking ourselves 5 raised to what power is equal to 25? Well, that would be 2, because 5 to the second power, 5 squared, 5 times 5 is 25. All right, so and then 3 minus 2 is 1. So that's the same answer that we got here. Okay, so it works. The quotient rule works. All right, now let's move on to the power rule. All right, so the power rule says if we have two numbers a and b, and we're doing a raised to the power of b, base c, then that's the same thing as b times the log of a base c. Okay, this is not blog here. This is b times the log of a base c. All right, so let's see why let's prove the power rule. And whoops. Did I skip it? Oh, I forgot to write it. Okay, that's all right. You know what? And actually, I'm just going to do an example of this. Hopefully, after seeing the example, it's not going to be an actual proof, but hopefully after seeing this example, the power rule will make sense to you. It'll seem intuitive. So let's say that I just changed this b to, I'm just going to pick a number 3. Okay, easy number. So I have the log base c of a to the power of 3. Well, I can rewrite a to the third power as a to the second power times a. Hopefully you'll agree that a to the second power times another a is a to the third power. So all I've done is I've written this another way. Okay, I've written this another way over here. But now I have two things multiplied together, so now I can go back and use the product rule, which tells me that when I have two things multiplied together, then that's like the log of the first thing plus the log of the second thing. Okay? Or the log of the second thing plus the log of the first thing. Actually, the order wouldn't matter there. So this is equal to the log base c of a squared plus the log base c of a. All right, but I can do that same kind of trick, and I can I can sort of peel off another a from this. So a to the second power is the same thing as a times a. So this whole thing is, I'm just going to rewrite this as a times a. Okay, and then I still have this plus the log of a there. Okay, and then again, I can use the product rule over here. And since I have two things multiplied together, I can use the product rule, and I can say that this is, I ran out of space over here, so I'm going to continue over here. So this is equal to the log base c of a plus the log base c of a again. All right, so I used the product rule on this, and then I have this plus this other log of a. Okay, that's still there. Okay, so basically what we're doing here is we started with this exponent of 3, but then we kept peeling off a's, and we ended up with log of a plus log of a plus log of a. We ended up with 3 of them. So another way of writing this is just 3 times the log of a, okay, base c. So hopefully, I used the example where the exponent was 3, but hopefully it'll make sense to you if the exponent had been 4, let's say, and I kept peeling off a's the same way that I did before, I would end up with 4 of these. So I would have to say 4 times the log of a in the end. If this exponent over here had been 1,000,000, then I would have had 1,000,000 of these in the end, and it would just be 1,000,000 times the log of a. So whatever this exponent is, it's just that number times the log of whatever this base over here is. Okay. All right. Good. So that's the that's the power rule. Okay. Whatever this number is, that's going to end up as a coefficient in the front. Okay. So let's do an example of the power rule. All right. We're going to do this 2 different ways. So we have 9 to the second power. Oops. Let me get that cursor out of the way. All right, so we have 9 to the second power. We want to figure out what's the log of 9 to the second power to a base of 3. So we could figure this out just by doing 9 squared first and saying that this is the same as log base 3 of 81. And then we'll just ask ourselves, 3 raised to what power is equal to 81? Well, let's see. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So 4 times. So 3 to the 4th power is 81. So the log of 81 base 3 is 4. Okay, now let's solve this another way using the power rule over here. So this would be the same as, we're going to take this exponent and use it as a coefficient. So here's our exponent here. We're just going to use that as a coefficient and then write everything else the same but without the exponent now. So we have 2 times the log of base 3, 9. Okay, now we have to ask ourselves, 3 raised to what power is equal to 9? And that would be 2. 3 to the second power is equal to 9. So this is 2. And it's also being multiplied by 2. That's just a coincidence. This and this are not always going to be the same, but they are in this example. So we have 2 times 2 here. And 2 times 2 is 4. All right, so we did end up with the same answer. Okay, so I believe that is it. I'm going to end the video there, and have a great day.